In this video, we're going to look at graphing y equals -4 cosecant 1/3 x. And the strategy here is we're going to use the fact that the cosecant is the reciprocal of the sine. So what you'll see graphed down below here is the graph of y equals -4 sine of 1/3 x. So just a real quick review, the way we got the period here is we did 2 pi divided by the 1/3, whatever's multiplied by the x, usually denoted by the variable omega. And so that's how we got this period of 6 pi. The -4 is going to do two things. The negative is going to flip the sign over, so instead of going up and then down, it's going to go down and then up. It's going to reflect it over the x-axis. And the 4 is the amplitude, so we'll reach a minimum of -4 and a maximum of +4. So that's already graphed for us. Now, to do the cosecant graph, we're going to use this reciprocal property, and we're going to look at really specific cases here. And the first case is when this stuff right here, this stuff comes out to be 0. Okay, so let's mark those points on our graph. Where does -4 sine 1/3 x come out to be 0? That's all these places. Now let's think about how that would happen. That's only going to happen if the sine of 1/3 x comes out to be 0, because then you would multiply it by -4 and get 0. Alright, so we have all the x's here where the sine of 1/3 x comes out to be 0. So what's going to happen to the cosecant of 1/3 x at those points? What's going to happen here? If the sine is 0, the cosecant is undefined, right? So no matter what else is happening around here, whether it's you might be doing horizontal shifts later by adding something or amplitude change, doesn't matter. If the cosecant of the 1/3 x part of that equation is undefined, you don't have an output. So those are the places where we're going to have our asymptotes. So let's go ahead and draw those in. Any place where the sine graph came out to be 0. Alrighty, so the next thing we want to do is we want to look at the max and min spots of our sine graph. So let's pick one of those. Let's say I pick this minimum point right here. Okay, so that minimum point is happening at -4. So this value right here has to be +1, excuse me, to make a -4. So at this particular point, the sine of 1/3 x would have to be, right here, would have to be 1 to multiply by -4 to come out to be -4. Okay, so now what is the reciprocal to get the cosecant at that same value of x? We don't even have to figure out the value of x, okay? We can just look at the graph to do this. Certainly we could find this value of x and plug it in, but that's more work than we're going to need to do. I don't want to explain to you how these points are easy to find on the graph by just using the graph and not plugging in values. Okay, so we know right here at whatever value of x this is, the sine of 1/3 x had to be 1 to then get multiplied by the -4 to give this output. So what's the reciprocal of the sine of 1/3 x? If the output's 1, the reciprocal is 1. The reciprocal of 1 is 1. So that tells me then that at that same value of x, my output for my cosecant is also -4. It's also going to be right there. Okay? Really important to understand here that we can't use this reciprocal property for every single point. All right, and let's do one more of these hill and valley, and then we'll go back and talk about that a little bit more. So let's go up to the top of this hill and look at this x value. Actually, let me make it red to highlight we're looking at the x value on our sine graph. Okay, so that output right there is 4. So let's think about what would this y value have to be, or what would the output of sine 1/3 x have to be in order for the output to be 4? Well, if I'm multiplying by -4, this is going to have to be -1. Okay, so now I know the reciprocal of that is also -1, and I multiply that by the -4, and I also get 4. So this is a common point. Now, hopefully I don't have to convince you that for all these hills and valleys, bottoms of valleys and tops of hills, the cosecant graph that we're looking at is going to share or intersect a point with the sine graph. Now from there, we know that the general shape of a cosecant, and we can just fill in the U shape. Now this is where I really want to highlight, we cannot use this reciprocal property at every single point, right? It was important. I was just looking at the outputs for the sine of 1/3 x, not including the -4 when I was thinking about reciprocals. All right, check this out. You see what I mean? Let's say I have this point right here. The output is 2, right? On the sine graph, the output is 2. I can't just take the reciprocal of 2, which is a half. That's not the y value on my cosecant graph. It's not just that reciprocal. It's more complicated than that because of the change in the altitude. And there is a little formula for figuring that out, but I think it's more than we need to do here. If we need really super detailed points, we can go to Desmos and get more detailed points in our U shapes. But most instructors are going to be pretty happy if you can come up with the asymptotes and the U shapes. And if you need more detailed information, you could use an online graphing tool like Desmos.